Hello, everybody, and welcome back. Still talking policies, and this time with the SDLC. So, the ISO has a section in 27002 called Information Security, Information Systems Acquisition, Development, and Maintenance. And that's going to focus on the security requirements of information systems, on the applications, on the code, from the very conception to its destruction. So this sequence is referred to as the Systems Development Lifecycle, or SDLC. Particular emphasis is put on vulnerability management to ensure integrity, cryptographic controls to ensure integrity and confidentiality, and the security of system files to ensure confidentiality, integrity, and availability. So the domain is going to that is constructed here applies to in-house applications, outsourced, and even commercially developed applications. So cryptography, of course, as we know, focuses on the proper and effective use of cryptography to protect CIA, which we talk about in a different lesson. So this is really where we're going here. Most cybercrime is opportunistic, right? So that means criminals are taking advantage of vulnerabilities largely in our applications. So information systems, applications, and the code does not have embedded security controls that it leaves us exposed to undue risk. Now, these are the objectives that we'll be working on. Notice cryptographic components, also part of Chapter 10 of our book. It was covered elsewhere, right? So we're just going to focus on SDLC. Now, keep in mind there's also some NIST guidance associated with the SDLC along the way. And so some of the ISO and NIST guidance is listed on page 301 of the book, right? And in applying all of these system security requirements, right, we want to remember that any web-based application, right, is linked, for example, to a back-end database. So if the code we use in this web-based application isn't thoroughly vetted, it can have vulnerabilities. That's common. And so and we can't find all the vulnerabilities, but a hacker that finds them is able to bring us down, like through a denial of service attack, and they can run then code on our hosting servers or applications, and they can try and trick our database into disclosing information. So we want to try to avoid all that. So we have system security requirements. So these security should be a priority objective. So we have this SDLC, the Systems Development life cycle, and under that we have SDLC also, but that's known as Software Development Life Cycle. And so security should be a priority objective during the design or the acquisition of any of these application systems or code development. And if we try to retrofit security or put security in later, it's more expensive, it is resource intensive, and it just all too often doesn't work. We want it in the design process and to be tested. So it has been proven time and again that early identification of secure requirements is cost effective and the most efficient. Now, to make that point, right, software is a skin that surrounds our civilization, right? It's everywhere, and it gets more so every single day. So we live in a connected world, and today that means software is in our home, in our car, in our workplace. It's everywhere. Anywhere we go, software is running in the background, powered by trillions of lines of code and complex systems. So think about this. A high-end car has more lines of code than an F-35 fighter jet, for example, right? It's got 100 million lines of code. So now think about the complexity of designing and engineering a vehicle with 100 million lines of code, right? Not to mention that it all has to work every time in critical systems. A car isn't a blue screen, right? We can't get away with things. So the challenge then becomes our software development and the policy applied to that. So software plays an even larger and larger role all the time. And it's important that we get everyone together, right? It's kind of the price of entry to convert and use this DevSecOps approach. Remember, development, which is writing the code, is meant for speed and quality. Security integrated in early is meant to add those security components and get tested along the way. And ops is about stabilized applications and monitoring. And so merging the three into DevSecOps is a very positive approach along the way. Now, the results otherwise can be devastating. Software fault is also known as a defect, right? Which comes about when the expected result doesn't match the actual results. It can be an error, a flaw, a failure, or a fault in a computer program. So most bugs really come up from mistakes and errors made by developers or architects. And so we want to be aware of this in the conversations. Be aware also that as you're having conversations and writing policy, that terms like fault, failure, and error can have slightly different meanings. So you want to define those up front in any policy. If you go to a book, you'll get one set of definitions, very similar but different, maybe in Wikipedia. And of course, if I went to IEEE, right, they may have a different set of definitions. So we want to define those up front in the policy. Also, as we're doing the software development lifecycle approach throughout, we want to make sure that we are applying it through the appropriate project management approach that incorporates the code writing and security and operations and the customer. And the common approaches are waterfall project management or agile. And you can see waterfall in red with its specifications, teamwork, change requests, and customer involvement versus agile. They're just different, but they both have advantages used at the appropriate time. So I just wanted to point that out in the process. So then what is SDLC, right? SDLC, or the Systems Development Lifecycle in this case, is going to provide a standardized process for all the phases of any system development or acquisition effort, right? So as defined by NIST, the SDLC comes in 5 phases: initiating, development, implementation, operational, and disposal. The definitions are recorded on this slide. You can pause and review them, or in the book on page 302 and 303, they go into a slightly different, a slightly more in-depth approach. That is up to you. So I will point out that in the development and acquisition phase, that it's a key security activity is conducting risk assessment in the development and acquisition phase. So I think that is very, very important. Also, I would like to point out that in the implementation phase, in the federal government, this process can be known as the certification and accreditation, or C&A phase. Sometimes you will use it to get a certificate to operate, for example. And then in the operational phase, the systems and products are in place and they're operating, and enhancements or mods are going to be made, developed, tested with hardware and software, etc. So configuration management and change control become essential to ensure the required security controls are going to be maintained, and that should be an important part of your policy. And you even want to do periodic testing and evaluation. Vulnerabilities are going to be identified after implementation, and so that can't be ignored. It's going to happen. There are bugs in every software program. So you want to implement these compensating controls while the fixes are being developed. By those I mean configuration management and change control is very important aspects. Okay, I am going to take a short break in a moment. This is more about those definitions of fault and failure. Like I said, there are guides out there. There's Wikipedia. There's the book. IEEE will have its own definitions. Make sure you clarify those when you are considering your definitions in your policy statement. Notice I kind of turned it into an example, getting away from computers for just a moment to a patient-doctor exchange, right? Trying to make that equivalence, right? So software faults and medical problems is the analogy I was trying to make here on this slide, just as background information. So we'll take a short break and come back with SDLC and commercial off the shelf.